we are tasked to choose two different tests in identifying convergent or divergent series, and I chose ratio test and alternating series. So first, we are going to discuss the ratio test. In ratio test, we have three conditions. If we let the limit of the absolute value of an plus 1 over an from n approaches to infinity is equal to L. So if the limit is less than 1, then the series is convergent. If the limit is greater than 1, the series is divergent. If the limit is equal to 1, then you can make any conclusion, or the series is inconclusive, or which means it needs another test. So now let's proceed to example number 1. First example, we have the series of 3 raised to n over n factorial from n is equal to 1 goes to infinity. In order to determine whether this series is divergent or convergent, everywhere there's an n, we're gonna plug in n plus 1 and divide it by the original. So our an plus 1 is 3 raised to n plus 1, and our n over n plus 1 factorial, and our an is 3 raised to n over n factorial. And now we're gonna substitute this into this. So we have the limit of 3 raised to n plus 1 over n plus 1 factorial all over 3 raised to n over n factorial. In order to simplify this, we're gonna do the extreme and mean. So n factorial times 3 raised to n plus 1 is 3 raised to n plus 1 times n factorial, and 3 raised to n times n plus 1 factorial is 3 raised to n, the quantity of n plus 1 factorial. And now we will also simplify this in order to cancel out the same terms. So in simplifying this term, 3 raised to n plus 1, we saw that, for example, 8 raised to n times 8 raised to 1. So we saw that they have the same bases. So what we're gonna do is pag-iisahin natin yung dalawang bases na to at magkakaroon ng addition operation between two exponents. So became 8 raised to n plus 1. In this case, kabaligtaran naman yung mangyayari. So itong 3 raised to n plus 1 is magiging 3 raised to n times 3 raised to 1. So we have the limit of 3 raised to n times 3 raised to 1 times n factorial. And para naman i-simplify natin to, meron tayo, so we have n factorial is equal to n minus 1, n minus 2, and so on and so forth. Tsaka lang tayo titigil kapag n factorial na lang yung natitira dito sa yung matitira. And now, so let's simplify this n plus 1 factorial. So n plus 1 is equal to n plus 1 times n plus 1 minus 1. So dito we can cancel out the 1 minus 1. So n factorial na lang matitira. So we have 3 raised to n times n plus 1 times n factorial. So we can cancel out the 3 raised to n tapos n factorial. So yung matitira na lang is 3 over n plus 1. In order to determine if this series is divergent or convergent, we are going to get its limit. So we need to divide each term to the highest exponent. So 3 divide n over n divide n plus 1 divided by 1 divided by n. So 0, 1 plus 0. So the final answer is 0. So the limit of 3 over n plus 1 from n approaches to infinity is 0. So since the limit is 0 or less than 1, therefore we conclude that this series is convergent. Next, we have the series of n over 4 raised to n from n is equal to 1 goes to infinity. So we are going to plug in an plus 1 and divide it to the original. So our an plus 1 is n plus 1 over 4 raised to n plus 1. And yung ating an is the original, or n over 4 raised to n. And now let's substitute this into this. So we have the limit of n plus 1 over 4 raised to n plus 1 all over n over 4 raised to n from n approaches to infinity. So extreme n means, so we have the limit of 4 raised to n times n plus 1 over n, or over 4 raised to n plus 1 times n. And now let's simplify. So yung masisimplify lang natin dito is itong 4 raised to n plus 1. So ito is magiging, so we have the limit of 4 raised to n times n plus 1 all over 4 raised to n times 4 times n. So we can cancel out the 4 raised to n. So yung matitira na lang is n plus 1 over 4n from n approaches to infinity. And now we will get the limit. So the limit of n plus 1 over 4n. So divide natin sa variable na may highest exponent. So n divide n plus 1 divide n all over 4 n divide by n from n approaches to infinity, or kahit wala na to. So we have 1 plus 0 over 4 or 1/4. Since 1/4 is less than to 1, so therefore this series is convergent. And now let's proceed to alternating series test. So we have two conditions here. So if b sub n plus 1 is less than or equal to b sub n for all n, and the limit of n approaches to infinity is 0, then the series is convergent. And second, if b sub n is greater than 0, it fails the divergence test or not equal to 0. So let's proceed to the first example. So we have the series of negative 1 raised to n times 1 all over n raised to 2 from n is equal to 1 goes to infinity. So in this example, our bn is 1 over n raised to 2 and our an is this whole series. So 1 raised to 2 lang yung gagalawin natin and i-disregard natin itong an, our bn and a sub n. So first we have to determine if b sub n plus 1 is less than or equal to b sub n. So our b sub n plus 1 is 1 over n plus 1 raised to 2, and our bn is the original, which is 1 over n raised to 2. So in order to know or prove if 1 over n raised to 2 is greater than 1 over n plus 1 raised to 2, so let n is equal to 1 and 2. Let's prove if bn plus 1 is less than or equal to b sub n. So let's substitute. So b sub n plus 1 is 1 over n plus 1 raised to 2 less than or equal to the original. So let's substitute n or 1 to our n. 1 over 1 plus 1 raised to 2 less than or equal to 1 over 1 raised to 2. So 1 over 1 plus 1 is 2 raised to 2 is equal to 4. So we have 1/4, and this is 1 over 1 raised to 2 is still 1, so we have 1. So we saw that 1 is greater than 1/4. Next, let's substitute 2 to our n. 1 over 2 plus 1 raised to 2 less than or equal to 1 over 2 raised to 2. So 2 plus 1 is 3 raised to 2. So we have 9 less than or equal to 1 over 2 raised to 2 is 4. So we know that 1/4 is greater than 2, 1 over 9. So therefore 1 over n plus n raised to 2 is greater than 1 over n plus 1 raised to 2. So let's proceed in getting the limit of our b sub n. So the limit of 1 over n raised to 2 from n approaches to infinity. So we know that the limit of 1 over n raised to 2 is 0. So dito nasunod yung condition number 1. So we can conclude that this series is convergence or converges. Next example, we have the series of negative 1 raised to n plus 1 times 5n plus 3 over 2n minus 1 from n is equal to 1 goes to infinity. So I said earlier that we will disregard the a sub n. So yung gagamitin lang natin is itong b sub n. So b sub n plus 1 is 5 times n plus 1 plus 3 over 2 times n plus 1 minus 1, and yung ating original 5n plus 3 over 2n minus 1. So let's simplify this. So 5 times n is 5n, 5 times 1 is 5 plus 3 over 2 times n is 2n, and 2 times 1 is 2 minus 1. Copy the bn, so 5n plus 3 over 2n minus 1. So pwede pa natin i-simplify ito. So we have 5n plus 8 over 2n plus 1 less than or equal to 5n plus 3 over 2n minus 1. So, now let n is equal to 1. So substitute lang natin yung 1 dito sa ating equation. So 5 times 1 is plus 8 over 2 times 1 plus 1 less than or equal to 5 times 1 plus 3 over 2 times 1 minus 1. So we have 5 plus 8 over 2 times 1 is 2 plus 1 is 3 less than or equal to 5 times 1 is 5 plus 3, 8, 2 times 1 minus 1 is 1. So we have 13 over 3 less than or equal to 8. So we know that 13 over 3 is less than or equal to 8. So since 8 is greater than or equal to 13, so first condition is, so tama to. So second, kunin naman natin yung limit ng b n plus 3 over 2n minus 1. So we have the limit of 5n plus 3 over 2n minus 1 from n approaches to infinity. So we will divide each term by the highest exponent. So 5n divide n plus 3 divide n over 2n divide n minus 1 over n. So 5n divide n is 5 plus 0 over 2n divide n is 2 minus 0. So we have 5 over 2. Since the limit is 5 over 2, so it fails the divergence test for not equal to 0. So this series is divergent. So that's the end of our discussion for today. So I hope you learned something about our topic for today.